Welcome to Romeo Maths and Science class. Today, we want to look at how we can answer these questions on the board under the topic kinetic energy and potential energy. All right, let us look at some formulas that we can use. All right, from definition of kinetic energy, where we said kinetic energy is the energy possessed by a body in motion. All right, mathematically, we can say that kinetic energy is equal to half multiplying the mass of the body, right? The mass of the body times velocity square. We square our velocity. So we can reduce it as KE, all right, where KE represents kinetic energy, equal to half multiplying the mass of the body times velocity square, as we can see. Now, we can make the mass the subject. So, our mass will be equal to 2 multiplying kinetic energy divided by velocity square. So we can use this formula if we have been asked, all right, to calculate the mass of the body. And also, we can be asked to calculate the velocity of the body, and the velocity of the body will be equal to square root of 2 multiplying kinetic energy divided by the mass. So we can have these formulas here. All right, there are some instances where our velocity will not be given to us. Therefore, we can also break the velocity down. All right, so from kinetic energy, where we have half multiplying the mass times velocity square. Now, our velocity can also be given as displacement over time. So we can use D to represent the displacement and T to represent what? Time. In some instances, we also use distance over time, all right? So we can use D over what? T. So we can substitute this formula, that D over T, into this. And our kinetic energy can also be given as half multiplying the mass, multiplying distance, that is distance over time, all squared. All right. And we can break this formula down. All right. That will be D squared over what? T squared. And we can simplify it as, that is mass multiplying our distance squared, all divided by 2 multiplying our time squared. So we can also have this formula for kinetic energy, all right, for kinetic energy, as we can see. We can also have these formulas based on the question and the type of formula we can use. All right, let us also look at potential energy. Now, when we say potential energy, we say it's the type of energy possessed by a body at rest. So we can also say that potential energy, all right, potential energy mathematically, we can use PE to represent it. Mathematically, potential energy will be given as the mass of the body, all right, the mass of the body, times gravity, acceleration due to gravity, okay, that is G, times the height of the body, H. So in short, we say potential energy is equal to the mass times gravity times what? Height, as we can see here. And again, our mass, we can be asked to find mass. So the mass will be equal to potential energy, all right? Potential energy divided by gravity times H. And also, we can be asked to find the height. So the height will be equal to potential energy divided by mass times gravity. Don't forget the unit. Our kinetic energy is measured in joules, all right? Our mass is measured in kilogram, and our height is measured in meters. And again, our gravity is constant. That is 10 meters per second square, approximately. All right. And our time is measured in seconds. All right. And we should be able to know that 1 kilogram is equal to 1,000 grams as a unit convection. And also 1 meter is equal to 100 centimeters. And also 1 hour is equal to 3,600 seconds. So we can use these conversions to do calculations. All right, with these formulas, let's see how we can answer our question number 1. All right, so from number 1, an athlete whose the mass of the athlete is given to us, all right, and that is 75 kilogram. Runs a 400 meters race, so displacement, or we can say distance is given. Our D is 400 meters, all right, in 52 seconds. So time is given. That is 52 seconds. And we have been asked to calculate kinetic energy, as we can see. So kinetic energy is equal to half multiplying the mass times velocity squared. Now from this formula, our mass is given, but velocity is not given. So we can say that, but velocity is equal to distance over time, or we can say displacement over time. So our distance is 400 and our time is 52. So we are going to divide this, and that will give us, that is 7.6923 meters per second, as we can see. So now that we know our velocity, we can calculate for the kinetic energy. So we have this times our velocity now is 7.6923 all squared. So when we fix this into our formula, let's see what we are going to achieve. That is half multiplying this times this, and that will give us approximately, we have 2218.9305 joules, all right, as we can see. So this is how we can calculate for our kinetic energy. Let us look at the second one. The second one, to the mass of the body is given to us. The mass is given to us as, that is 10 kilogram, all right? And also the height is given, all right? The height is given as, that is h, all right? The height is given, that is 200 centimeters. But here we change to meters, so we divide by 100, and that will give us 2 meters. And again, our gravity is given as 10 meters per second squared. So here, our potential energy is equal to mass of the body times gravity times height. So we fix our mass, 10, times gravity, which is 10, times our height, which is 2. And when we multiply this, we are going to get 200 joules. Don't forget that potential and kinetic energy are measured in joules. So this is how we can apply these formulas here to solve these questions. Try question number 3 and number 4 and leave your answer in the comment section. Thank you.